Hello everyone, I am Pragya Srivastava, an educator on Unacademy. Follow me on Unacademy Learning app to see my many more courses. And please do rate, review and share the lecture. And this course is all about canal regulators to regulate the flow of water through your canals. Whenever we need water to reach to our field, a distribution channel takes off from the parent channel. The alignment of the distribution channel is called offtake alignment, and a offtake alignment is needed to be designed when a distributing channel takes off from parent channel, and you should be very careful while designing your offtake distribution, because an unbalanced offtake results in formation of a ZT. The reduction in sectional area caused by the ZT could be made up by the scouring of the bed along the line of the deviated current. You can see here, this is your parent channel and this is your offtake canal, and this is your parent channel that is actually diverted here, and these are called cross regulator, and this is your head regulator. And here also you can see a parent channel, and here the design is made in such a way that the alignment actually somewhat changes like this, and this is your parent channel and cross regulator is applied here. Here this is your head regulator and this is your distributing channel. Here what we see that this is what actually I was talking about. If the alignment is designed in this way, then what happens? This is your ZT, this portion where actually silt gets deposited, and it can cover your bed as well. And this one here you can see there is no angle, there is very smooth transition from parent channel to the distribution channel, and no sharp angles like this is actually made here. So this type of alignment is said to be the best alignment. Best alignment is the one when offtake makes angle 0 with the parent channel. You can see here there is very smooth transition with no proper angle, no sharp angle made anywhere. Now come to these head regulators and the cross regulators. We have seen that we have applied some head regulator to the distributing channel and the cross regulator to the parent channel. Why is it needed? These regulators regulates the supplies of the off-taking channel and the parent channel respectively, and it serves as a meter for measuring the discharge entering the off-taking canal. There are many uses of these head regulators and cross regulators. They control the entry of silt in the off-taking canal. They help in shutting off the supplies when not needed in off-taking canal or to be closed for some repair work. We need a cross regulator which is actually provided on the main canal at the downstream of the offtake to head up the water level and to enable the off-taking channel to draw the required supply. Some more of its uses: during periods of low discharge in the parent channel, the cross regulator rises water level of the upstream and feeds the offtake channel in rotation. And these regulators helps in absorbing fluctuations in various sections of the canal system and in preventing the possibilities of breaches in tail reaches. And the effective regulation of the whole canal system can be done only with the help of these regulators. So many users, and it's actually very important, acts as a safety device or emergency device as well to control the supply of your water level, discharge through of the channels. Now let's try to understand one more term which is actually which is used in cross regulation works, that is your canal scape. What is canal scape? Canal scapes are structures constructed on an irrigation channel for disposal of surplus water from the channel. And sometimes scapes are provided in the head reaches of main canals to scour out the bed silt deposited in the head reaches. The necessity of providing scapes. Why is it necessary to provide scapes in your canals? Because sometimes there is difficulty in regulation at the head of a channel, and sometimes there is excess supplies comes in upper reaches. Why? Because of excessive rainfall. Then also you need to take care of the extra discharge coming to your channel. Then sometimes there is sudden closure of outlets by the cultivators. Why? Because of sudden dip in the demand or stoppage in demand. Then sudden closure of any off-taking channel. To take care of that discharge, we need canal scapes to let go of the excess water. And scapes are therefore an essential safety valves for the channel. There are different types of canal scapes that can be provided based on the purpose that it serves. We can have three types of canal scapes. One is canal scouring scape, then it can be a surplus scape, or it can be a tail scape. We call it canal scouring scape when it is constructed with the purpose of scouring off the excess silt from time to time. It is called surplus scape when the scape is constructed with a view to dispose of the excess supplies of the parent channel. And then it is called the tail scape when the scape is constructed to maintain the required FSL at the tail end. Based on the structural design of the scape, we have divided it in two types. One is regulator or sluice type, and the other one is a weir type. Now let's see. We call it a regulator or sluice type, which is actually more like a small regulator provided in canal back and has gates supported on piers. Weir type is more like a weir with crest of the weir wall at FSL of the channel at the site of scape. So, scapes are essential safety valves for the canals and should be constructed at regular intervals. The canal leading the surplus water to a natural drain is called scape channel. The capacity of a scape channel should not be less than 50% of the capacity of the parent channel at that point. And please go through this chapter, and very simple to understand. These are small terminologies with which you must make yourself comfortable. And in our next lesson, we'll be studying about cross drainage work. Till meanwhile, keep studying.